Okay, YouTube, in this video we're going to further explore the framing method by putting kind of all the pieces together. And so we've looked at stretches and shrinks, we've talked about reflections, we've talked about translation, transformations. What I want to do is kind of put all that together with the framing method in this video. And so what we're going to do is we're going to graph these curves here. We have a sine curve and a cosine curve, starting with this sine curve. And so let's recall that when we were discussing sine and cosine curves, these are functions of the form y equals a times the trig function, sine or cosine, of bx minus c plus d. But we're aware that our vertical translation is controlled by our d value out here, what we usually call a k value. Then our horizontal translation is controlled by the c value here, which we usually call an h value. And then we have reflections and stretches occurring because of our a value and also because of our b value in here. And so let's take a look here at what we get for the values of a, b, c, and d and how that affects the placement of our starting point and the dimensions of our frame. So let's go ahead and start with our amplitude. So our amplitude, always the absolute value of the a value here. So what we end up with is the absolute value of -3, which is 3. Let's go ahead and identify these here, I suppose. Our b value is 1. Looks like our c value is the opposite of negative pi halves, so we say pi halves. And it looks like we're lacking a d value. So I got a little ahead of myself here. But we say after identifying these, we have an amplitude of 3. Now the period, we say 2 pi over the b value here, which in this case is 1. So we have a period length of just 2 pi, which is just like a standard sine curve. So now in terms of starting point, we have c over b, comma d. Let's go and evaluate this here. So our c value, which is pi halves over b. Now our b value is 1. And this is comma d, which is 0. So if we simplify this, what we end up with really is pi halves comma 0. So we say pi halves comma 0 is where we're going to start our frame. So let's go ahead and construct this graph here. We're going to start at pi halves comma 0, which means we're going to start on the x-axis but to the right of 0. So I'm going to refer to this point right here as the x value pi halves, and we're going to say that the point pi halves comma 0 is kind of within this box. Now let's go ahead and construct our frame, starting with the height. Now the height of our frame, because the amplitude is 3, means we're going to go 3 above and 3 below this. So we must be at a maximum height of, looks like 3, and a minimum height of -3. So I'm going to label these out here, but we'd say our frame doesn't go through here. It runs through this starting point. This is the left side of our frame. So here's our left side. Now the length of the frame would be equal to the length of the period, and we say that the period is 2 pi. So now, because I only want one cycle, I'm going to kind of use up a lot of the real estate here. But that does not mean that this is 2 pi right here. What this means is that it's 2 pi plus pi halves. Or in other words, let's do this. We need to take the original x value, which is pi halves here, and we need to add on the period length. And so our period length in this case is pi halves plus 2 pi. And because 2 pi wholes is the same thing as 4 pi halves, we get pi halves plus 4 pi halves, which is really just a 5 pi halves measurement. So what we're going to do is we're going to say that this final x value here is 5 pi halves. We must label this one. We're going to extend our frame out to here and then work at setting up the partitions in our frame. So here's our frame. We partition it lengthwise down the middle, but also down this, vertically here halfway. So what would be this x value? The neat thing about it is we can always average two x values to find the midpoint of those two x values. That is to say, if this is pi halves and this is 5 pi halves, and we add those together and divide by 2, what we end up with here is 6 pi halves divided by 2, which is the same thing as 3 pi divided by 2. So this is 3 pi halves. And another way to look at this is also we could split this up into all just pi halves. We have pi halves. This would be 2 pi halves or pi. 3 pi halves. This would be 4 pi halves or 2 pi. And this would be 5 pi halves. But again, you could average, say, pi halves and 3 pi halves. I just want to show you this here. If you took pi halves plus 3 pi halves and you averaged these, just add them together, we get 4 pi halves. That's 2 pi. And we divide all these by 2 here. We would just get pi. And that's the same thing that we had articulated up here in the first place. So with everything in here and everything partitioned, we're ready to go ahead and drop in our sine curve. Now one thing we want to mention here is that our a value is negative. And because it's negative, it just means that our sine curve, instead of starting at 0 and going up to its maximum first, it's going to start at 0 and it's going to proceed to its minimum first. We'd say here's our sine curve, one cycle of our sine curve. So in terms of how this was affected by its equation values here, we would say that our a value of -3 caused the reflection and the amplitude to increase to 3. And it looks like that even though we had a period of 2 pi, looks like our graph was shifted right pi halves units. So for this last example here, same story. I want to look at a case where our b value is not equal to 1 and also that it's equal to something that is transcendental, has a pi in it. So we'd say let's go ahead and start with identification of our values that we need to determine these here. So we say a, looks like a is 2. Our b value, now interesting story is that b is 2 pi. That is the coefficient of x, and the coefficient of x right now is 2 pi. Our c value, which would be a term added or subtracted onto or off of our x term inside the parentheses, doesn't exist. We don't have a c value here, but we do have a d value, -1. So going ahead and thinking about this out loud, we can see that, well, yeah, the amplitude, which is also the absolute value of a, it's going to be 2. It looks like the period of this graph, we have 2 pi over b. The interesting thing is our b value is 2 pi. Ooh, so what happens here? It just means that the period is 1. So starting point wise, let's go c over b comma d. We have c over b, so 0 over 2 pi, comma d, and we have -1. So it looks like we get 0, comma -1. It looks like we have everything we need to go ahead and set up this frame. And so we're going to start this graph at the point 0, comma -1. I can kind of see that, of course that would be this point right here if we're calling this -1. So I'm going to put a little box around this. This is the starting point of my frame. So now with the height of our frame, the amplitude's 2, means we're going to go 2 above, so a maximum height looks like a positive 1, and our minimum height, as a matter of fact, is a -3. And so we've established the left side of our frame here. So now let's get with the length. Now we say the period is 1, and because we only want one cycle of this, I'm going to use a lot of this number line. I'm going to say that, let's just call this 1 then. So if that's 1, we have everything we need to go ahead and construct our frame. And this frame runs this way. Now the interesting thing is that this middle line, lengthwise, actually goes across at a height of -1. And when we partition it in half here, we say, well, what's halfway between 0 and an x value of 1? This would be an x value of a half. So we would say that this is an x value of a half here. If we split these in half, so it's interesting here, this would be a fourth, and this would be 3/4. But we get no pi's in our measurement here. So now that we've constructed our frame, we see that we have a cosine curve here, and that the a value is positive. So because all cosine curves start at their maximum, if they're not reflected, we'll start at our maximum. We're not reflected here. Here's our maximum, beginning of the frame. A fourth of the way through the frame, it's at its quote-unquote 0, and then it goes to its minimum, and then to its 0, and then to its maximum again. So in this particular instance, we can see that we have a graph that has an amplitude of 1, just like the parent cosine function, but was shifted down 1 and also had a period that was not equal to 2 pi. Cheers.